Continuing with our review of Algebra 2 and some Algebra 1 information, we're going to talk about solving equations in this video. The values of some unknown, for us that's usually a letter, x, y, z, a, t, s, it doesn't matter what the letter is, that make an equation true are called solutions or roots of the equation. And when we solve those and find those solutions, that's called solving the equation. Two equations with the exact same solutions are equivalent equations. So let's talk about the importance of the equal sign. I find that in mathematics, many times, the equal sign is overlooked. So the equal sign is a very important mathematic symbol. If two things are equal, then they are interchangeable. Every time I see an A, if it is equal to B, I can write B instead. If I have two equal things and I add anything to them, as long as I'm adding the same thing on either side of the equal sign, then the results of that will be equal, as long as I'm doing the same mathematic operation on both sides of the equal sign. So don't overlook the power of this sign. It's a pretty important thing. So let's talk about, let's just talk about solving linear equations. So a linear equation is one variable plus or minus a constant. Now we could have a coefficient to that variable. That's what A represents here. Here we have a coefficient A, a variable x, plus a constant B. And so that's what a linear equation looks like. If we want to solve linear equations, then we take the proper mathematic steps, how many ever steps that takes, to isolate that variable on one side of the equal sign. The way I teach this is if I have 4x's and I'm subtracting a constant of 5 and that equals a constant of 3, then I'm going to take anything that doesn't have an x in it and use proper mathematics and get it on the other side of the equal sign. And therefore I would have 4x equals 8. Well, x is attached to the 4 by multiplication, and I need to undo that mathematic operation. So what undoes or reverses multiplication? Well, that's division. So I would divide both sides by 4 and I would get x equals 2. So linear equations are variables with a degree of 1. If we have a variable with a degree of 1, it is a linear equation. You can see here this is nonlinear because there's a degree of 2. Here is a root, and here is a reciprocal term. So none of these are linear. So let's talk about solving quadratic equations. We have lots of techniques for solving quadratic equations. Remember, a quadratic equation has one term that is squared, that's what makes it quadratic, and has none or maybe one x term to degree of 1 and a constant. Constant could be 0 here, b could be 0. That's why I'm saying it may not have an x term, but it definitely will have a squared term. So that's what makes a quadratic equation. So if we're going to solve, we need to factor it, and we're going to use this zero product property to factor our quadratic equations. So if I multiply two things together, whether they're just two variables or whether they are two binomial factors, x plus a times x minus b, it doesn't matter. If I'm multiplying two things together and that product equals 0, well, one of three things happened. Either this factor equaled 0, or this factor equaled 0. It's the only way I can get a product of 0, or they both did at the same time. They were both 0. And that's where the word or comes in. It's not that and that. It is this factor equals 0 or that factor equals 0. It's the only way I got 0 as a result out of all that. So that's what we're going to use when we just factor quadratic equations. So here we have this quadratic equation, x squared plus 5x equals 24. Well, I need to make sure if I'm solving a quadratic that it's always set equal to 0. There is an exception to that where radicals are involved and those kinds of things, but we'll see an example on that. So first things first is we have to get 0 on one side of this equal sign. So we usually do whatever mathematics is necessary to get everything else on the other side of the equal sign. For instance, here we subtracted 24 from both sides so that now we have 0 on the right hand side and we have the minus 24 on the left hand side. Then we're going to factor, and remember we talked about this before, how you factor. You're going to say, what is the coefficient to my squared term? Well, here it's 1, so that's x times x. I need two numbers that when I add them I get positive 5, and when I multiply them I get negative 24. And that's how we came up with negative 3, or x minus 3, and x plus 8. So now the only way that product can equal 0 is either for x minus 3 to equal 0 or for x plus 8 to equal 0. So I'm going to take each one of those factors and see what x value would make that a true statement. That's how we solve quadratic equations, by factoring. So here, when x is 3, it's true that this equation equals 0, or when x is negative 8, it's true that the equation equals 0. So straightforward factoring, not really an issue. Here's the case where we don't have to worry about the right-hand side equaling 0. When we only have an x squared term, there's no x term, there's no, well, if there's a constant, we can move the constant to the other side and make it part of c. But when we just have a simple quadratic equation, we don't necessarily have to use that whole factoring idea and the sum of zeros to find our factors. We can indeed just isolate the squared term on one side of the equal sign and put the constant term on the other side, and then take the square root of both sides. One thing that we do need to pay attention to is that it is true, if I'm doing this backwards, one way to square something and get a positive 5 out of it is to take a positive square roots of 5 and square it. It is true that I will get 5 as an answer, but we also have to remember, if I take the negative square roots of 5 and square it, I will also get 5 for an answer. So when we're solving these quadratic equations and we're looking for all the possible values of x that make this a true statement, we have to remember the plus or minus as far as that is concerned. And that's true regardless of whether there's a translation or anything like that going on as well. So we'll real quickly look at these other examples here. So if we have this solution, we're going to take the square root of both sides. That will leave us the quantity x minus 4 on the left-hand side, but realize it will give us either plus or minus root 5 on the right-hand side. And then, you know, x is buried up with subtraction. What undoes subtraction? That's addition. So I'm going to add 4 to both sides, and those are my two possible answers that solve that equation. All right. Completing the square. Completing the square is something that is made very difficult when you look at something like this. I look at this and I think, okay. But if you'll put these symbols into words, and you're going to hear this a lot from me this year, our brain is made for language. Our brain understands language. It doesn't understand symbols as much as it does language. So we're going to work really hard, and this part of this will improve your ACT score for sure, is to turn what this jumble of symbols is actually saying into language so that it makes sense. And here's what it says. It says take the coefficient of your single variable 1 degree term, b. Take half of that and square it. That's what it's saying. Take half of b and square it, and add that to both sides. This is probably easier done when we actually have an example. Let's look at this example. If I'm going to complete the square, The very first step that I'm going to take is to get my constant on the right-hand side of the equal sign. I'm going to come over, and this is what I'm going to write. I'm going to write x squared minus 8x. I'm going to leave a space, and I'm going to take my constant using good algebra, meaning I'm going to subtract this positive 13 from both sides. So the positive 13 is gone from there, and it's over here on the right-hand side. And completing the square says take half of this value, well, half of that's negative 4, and square that. So that's 16. Well, because I can't change the value of what's going on either side, I can only change the way it looks. If I add 16 to the left-hand side of the equal sign, I best be adding 16 to the right side as well. So that's this step right here. You can see that's what they've done. But that's the process that I go through. Take half of the coefficient, make sure you keep up with the sign, square it, and add that to both sides. So let's continue to look here at the solution, if my technology will work for me. And it, for some reason, doesn't want to. Now let's try that. Okay. I have no idea why it's jumping around like that. We went there. We went there. So we have x minus 4. We'll hop back and forth. If I was going to factor that, that's a perfect square trinomial, right, which is x minus b quantity squared. We already said that's b would be negative 8, so it's going to be minus 4. And then the result here on the right-hand side is 3. So again, we're going to take the square root of both sides. Just like we saw in the simple example, that result could give us either a positive root 3 or a negative root 3. So we need to make sure we keep up with that. And there are the two possible answers that make that a true statement. So let's go back up here and look at this one. So we're going to do the same process. Let me see if I can do it really quickly here. We're going to take 3x squared minus 12x. Leave some space. I have a positive 6, so I need to subtract 6 from both sides. I take half of this value and square it. But wait a minute. That's only true if the coefficient to the squared term is 1. So I need to take care of that 3. I need to divide each term in here by 3 so that I can actually use that completing the square technique. So if I divide through each term by 3, I get x squared minus 4x equals negative 2. Now I can take half this, which is negative 2, and square it, which is positive 4, and I need to do that on both sides. So what I have here is x minus 2 quantity squared equals positive 2. I take the square root of both sides. That leaves me x minus 2 equals plus or minus the square roots of 2. And then I add 2 to both sides so that I isolate my variable. That's the solution that I'm looking for. So there are my two solutions. So again, completing the square is not difficult. It's just knowing the steps that you have to take and also knowing that that coefficient has to be 1 on the x squared term. So there we are. That's the result that we got. No worries. All right, the quadratic formula. Quadratic formula is a fail-safe way of finding your results, your roots, your solutions, your answer. This would be the one case, just a handful of cases in pre-calculus and calculus, where I'm going to say, you know what, just memorize that formula. Just memorize it. It's not that hard. I was made to memorize it in high school, and I still know it. Negative b plus or minus the square root of the quantity b squared minus 4ac over 2a. Not difficult at all. I'm about to the end of this video. We're going to have 2 videos here for this lesson. So I'm going to stop the video now. We'll pick up here, and the second video will be really short. We'll work an example or 2 using the quadratic formula. So look for the next video.